In this video, we're going to go over these problems from Module 3A, Graphs of Algebraic Function. So as I said before, make sure to try these problems on your own first. If you have not tried already, pause the video now, try number 1, then unpause it and check your work with what I go over. So pause the video now. Okay, so let's go over this problem. So this function right here, f of x, is a piecewise function. That means that more than one rule is defined to describe the function, and that rule is divided by domain. So from -5 to 0, we follow absolute value of x. From greater than equal to 0, we follow rule of x squared. So let's find domain of the function, which means this one, entire thing. So domain, as we can see, start from -5 and go to 0. Then it goes to 0 and also includes 0. So combining these two domain gives us domain of the entire function. So let's find the intercept for a second problem. So here, locate any intercept means either x or y intercept. So either one's fine. So let's review x-intercept and y-intercept. We can find x-intercept by solving the function equals 0. And we can find y-intercept by plugging 0 to input quantity, then whatever this gives us. Okay. So let's see. So let's find the y-intercept. That means I need to plug 0 in. I need to plug 0. And we have to be careful here. Where do we plug it in? Since 0 is in this domain right here, x is greater or equal to 0, we have to plug 0 here. 0 square. So 0, 0 is a y-intercept. But 0, 0 is also x-intercept. So this is one of those cases where x and y-intercept are equal. 0. Okay. But it's not always. So here, for this one, 0, 0 is the answer. But if it was different, let's say we had different x-intercept, but then x-intercept also could be answered because he said locate any intercept, either x or y-intercept. So now let's try to graph the function. Okay. So let me draw x and y axis first. So here, we want to draw one piece at a time. So I'm going to draw this one first using blue color. So from -5, somewhere here, all the way to 0, but at 0 we should have open circle. So I'm going to draw open circle here to indicate that along the line somewhere here, on the y-axis, the function has to have open circle for this piece right here. So we know the absolute value function, if I plug -5, I should get 5. If I plug, let's say, -3, I should get +3, right? Because taking absolute value. So this is one of the toolkit functions. So you also should be familiar with this shape, basic shape of this graph. Okay, so right here. So if I were to draw just absolute value of x, it will be actually go like this, right? Like a V shape. But because we're only drawing this function up to 0 only, and not including 0, we stop it here. Okay, so let me draw it this and open circle. Okay. So then using red color, I'm going to draw the second part. This is when x is greater than or equal to 0, we have square root of x. So square root of x, let's say 1, 2, 3. If I plug 1 in, I should get 1. If I plug 2 in, I should get 4. Let's say somewhere here, 4. And we know this is a parabola shape. Again, this is one of those toolkit basic functions that we should be familiar with the shape. Now here we can also plug 0 in. So here 0 actually happens to be here. So then we draw a parabola like this. So this graph right here, this right here is a shape of this function, this function right here. So again, piecewise does not mean piecewise in the graph. It means the two different equations or more than one equation to define the function. So we have more than one piece to define the function. So graph here is not actually a piece, it's one piece, right? This is all connected. That's not always the case. So this was part C. Now let's do part D. Based on the graph, find the range. Range is the collection of output quantities. So in this case, we can see that it starts from 0 and go up. So range is including 0 and positive infinity. So let's look at second problem. So given f of x equals x squared plus 3, transformations are applied to f of x. And the new function g of x is negative 2 times square root negative 2 times parenthesis x plus 5 close parenthesis square plus 6. List each transformation from f to g in words. For vertical horizontal shift, include appropriate numerical value. Okay. So here we have to compare these two functions and see what kind of transformations are applied. Okay. So it is helpful. Okay. Well, we must look at the original function. This is the original function, right? So let's see. Okay. First, we recognize it's 3 and 6, right? So let me actually write both. X squared plus 3. And we have negative 2, x plus 5, squared plus 6. So here we have plus 3, but here's 6. That means that it went up by 3. So vertical shift of up 3. Then let's look at input value. Here we have just x squared, but we have x plus 5 squared. Since it's plus, that means we actually have x minus negative 5. That means we went left by 5. So then we multiply by negative 2. When we see a negative number multiply, we have to actually analyze in two separate parts. We have negative number, so we can think as negative 1 and 2. So here we actually need to view as multiplying negative 1 times positive 2 times this function. So negative means we have reflection over x-axis because we're multiplying negative to the function, the entire function. And for positive 2, this is a vertical stretch. Vertical stretch. Since 2 is greater than 1, right? So these are just rules for transformation. Okay. Again, pause the video. I don't think I said it for a second problem. Pause the video and try this on your own first, then come back. So here we want to verify, or we want to check if this function f of x equals negative 3x cubed is even out or neither. So in order to do that, we need to see what f of negative x would be. So let's try to evaluate f of negative x. That means instead of x, we need to plug negative x as input. Like this. So then what do we get? We get negative 3. Negative x to the third is just negative x to the third. then negative negative gives me positive x to the third. So for f of negative x, we'll get 3x cubed. Okay. So if this negative f of negative x, if this was equal to this, then we have even function. Since 3x cubed and negative 3x cubed are not equal, they're not the same thing, right? So there is not even function. So we can establish that it's not even function. And if f of negative x equals negative f of x, then we have odd function. So here that's the case, because here negative f of x is negative 3x cubed, which is 3x cubed. So in conclusion, we can say this is same as negative f of x. So this is odd function. So what is odd function? This is odd function. The given function is odd. Okay, next problem. Another transformation problem. So again, pause the video, try on your own, then come back and compare your work with my work. So for the below graph, first identify the toolkit function. That means identify the original function. Then write down the equation for the graph using transformation from part A. So here, again, it is important for us to be able to recognize basic shape of those toolkit functions that I talked about in the first video. So this one we have V shape. So this one, the original function is absolute value function. So let me actually draw that. This is our original function, right? So our original function, let's write f of x equals absolute value of x. Now we have to recognize, we need to try to figure out what happened in terms of transformation. Okay. So why don't I actually put it this point right here. Okay. So what happened? Why don't we reflect first? So let's reflect over x-axis. Okay. So that means we have negative absolute value of x. So then I have this right here now. This graph. From here, we just need to shift it, right? We need to go left 3 and up 4. So think as moving this origin. We need to move this point to right here. Then from here, we need to go left 3 and up 4. So how do we write that? From negative x, we need to subtract, going left negative 3, and go up 4. So to simplify, we have absolute value x plus 3 plus 4. So this is the new transform, the graph of the one that already I shouldn't have used the blue, I guess, but yeah, this one right here. This graph right here. This highlighted graph is this right here. Okay. So again, it is important that we recognize which was the original function that transferred from. Okay, and that's a similar problem. Again, pause the video, try on your own, then come back and I'll go over. So same idea here. Identify the toolkit function, then write down the equation for the graph using transformation from part A. So this one is this right here. Or let me draw more accurately with different color. So again, we need to be able to recognize which is shape. So here, the original function is square root of x. Okay. So what happened? Seems like only thing that happened was left 2. So how do we go left 2? We take absolute value, x minus negative 2. And square root of x plus 2 is the, we do this again, this graph right here. And we can always check. Okay, so let's call it this is gx, g of x, the new transfer function, square root of x plus 2. Okay. So then we can try some points. G of negative 2 gives me negative 2 plus 2 gives me 0, right? So we have negative 2 comma 0 right here, which is on this graph. Okay, we can try another point. Let's say g of positive 2. Then we get 2 plus 2 equals square root of 4 gives us 2, which means 2 comma 2. So when it's 2, it's right here. So we can always check our answer by testing some points.